Hello, today I'm going to represent you how to implement C++ runtime reflection. Sometimes you have fields in your class, so for example string, int, boolean, and something else, and you might need to serialize them, for example to save some XML file or ES or something else, and restore them back. So when serializing, you are interested in the value itself. So for example, you could store in the name, for example, name Alice, Roger, or something else, and age. And when you are serializing, you also care about the type which is being used. So that could be, for example, std string or int, so some sort of C++ type. And then you are interested in the field name. So when serializing, you need to have in plain text, so those field names, so name, age, and so on. And simplest way to get name from the field name is basically try to stringify. So that can be done using C++ define. So you define some ID, and then if you pass through name to string, and you get it as a plain text. If you want to abstract field position within the class, so you need to use this special kind of macro for that purpose. So there exists this kind of offset off, so that one basically defines where that field resides correspondingly from the this pointer. So theoretically you could use this kind of pointer calculation. So if you have this pointer, for example person pointer, you could convert it to char pointers. Char is basically used here for calculating the pointer itself, and then you add their offset off and you get again character pointer back, so that is basically void pointer to that int, and then you convert to int type and you can actually assign some value to that one through pointer assignment. On GitHub you can find this kind of special test project which uses this special kind of define called reflectable, and it passes through the class name and also field type and field name itself. So this basically corresponds completely to this class structure, but additionally this reflectable actually creates some type definition of that class. This sample project simply tries to serialize some data to XML file, and then restore it back from that file. If you want to understand how it actually works, you can go to definition of reflectable define, and you can actually figure out that it's basically dumping all types and fields to the class itself, and additionally it creates additional function called getType, which is static for whole class, which obtains more information about fields. So if you want to understand how this works actually, so we can pick up the class name and then call from there getType. So if you go to definition of this getType, it will actually jumps to reflectable macro. So the function is defined here, but it's not visible because of macro expansion. But from here you can actually figure out its type. So I will actually return you this C++ type info, and you can get type info from there basically. And for example, if you want to print out the class name, so you can just do it like this. So this one will print out you the class information. So like you see, it's people, and basically name at the moment. So this at the moment I'm using C string A, which is actually Windows platform specific, but later on could be actually that I will try to port it to other platforms as well. So it might get replaced with std string or something. And if you, for example, want to get list of field which that class has, so you can just write it like this. So so you just iterate all fields and then you print out each field actually from there. So okay, let's check it through. So basically the class itself is people, and it contains two fields, group name here and people. And besides name here, so there is additionally offset where that field resides within parent class, and more information of the type can be found behind this type traits class. If you try to understand so how those defines actually works, so it's not so trivial to identify so what is expanded to what. And if you actually want to improve those defines, so you might need to use special kind of flags, so you can actually produce preprocessed file out of original source code. And this is useful when those defines gets really complex. Alternatives to defines is actually to produce your own custom tools. So for example, in Qt there exists meta object compiler, and what I have harvested several forums, so C++ reflection might be built in next C++ standard, so but it is not at the moment. So at the moment I'm trying to stick with the defines and using them. So main use case scenarios basically for serialization complex classes or structures. So either save them to file or, for example, send the message over internet or some custom server. And I have seen also that you can print complex structure recursively, but it's maybe not so useful at the moment. The previous example was for serializing and deserializing the whole class at once, but if we are dealing with the heavy XML structure, so serializing and deserializing everything might be time-consuming job. And the main question which I had, so is it possible to serialize and deserialize only what is required, so not everything? So if you are changing, for example, only one field, and that would be serialized in the XML. And I have created one example project which actually tries to generate Visual Studio C++ project, so that is XML file, and I will try to briefly explain in next slides how it works. Basically, main problem with all project generation tools like CMake or Premake 5 is that it's difficult to map so what parameters to which parameter it corresponds to in the property pages. And here I have tried to map directly API against the UI pages which we have in project properties, and partially map also to what we have in the XML file of project itself. So basically, if we go in the project configuration, we have their linker settings, and correspondingly we have linker settings also in the API itself. But in XML, this is named like link, so there is already some inconsistency in naming. And then if we go deeper, so from linker we can find out the debugging tab, and we have also in API wise also debugging property, and in the XML form that one does not exist. So it basically corresponds that if you try to expand all parameters, they would be listed over here basically. And if we go now deeper, so in the property pages we have generate the book info, and generate the book information we have in the file and on API level as well. And then we have correspondingly the value itself, so generate the book information, and which is saved as true parameter in the XML file, and on API level it's debug info underline true. So I have tried to map API against UI against XML. Basically, I have tried to construct API which would try to mirror or reflect user interface, but would also able to mirror the file format itself, so whichever approach is easier. Basically, whenever we are saving to file, so API should be as close as possible to used file format, so we can serialize data as it is, so without any explicit conversion function. And like we saw already, so the UI does not fully correspond to used file format. So in UI we might have, for example, linker. In file format there is a link XML node. From UI we have, for example, debugging tab, which does not exist on file format level. In UI we have generate debug info, and in file format it is written like generate debug information, so without any spaces. So terms are not fully identical, so we need to choose one of them. So normally we try to use UI naming, so if there is this linker or debugging, it is used as such. But when it comes to actual data to be serialized, so then we prefer to use file format naming instead. It may be a bit cryptic for end user to understand, but it makes sense to discuss this a bit deeper with the Microsoft itself, so those naming could be improved there as well on the file format level. And when it comes down to enumeration, so what I've came across that we might need to serialize this kind of values like true, false, which is a typical use case for Boolean. Also there is some, for example, windows and so on. So those could be either constant or generally defined values. So I've decided to add some prefix to those parameter, and prefix is added also here. So we have this kind of define macro, which is actually defining the enumeration name, the prefix for all enumeration values, and enumeration values themselves. But when we serialize the enumeration value, for example, the book info false, it will serialize only false on file format level. So if we start sketching how the class would look like, so first thing to do that we simply define some class, so I will not go in the name itself any deeper, but we could use for actually the previously defined enumeration, so I generate debug information, and we specify this field as generate debug information, so it's using directly the same naming as a XML file will have at the end. And this is now intentional because we want to serialize it by that name. And one question, so if we have, for example, code like this, so debugging, generate debug info, and we are assigning that that basically field to this value. So what would be required in order for this assignment to reach XML in general? And actually, one observation which we noticed that this actually should be a function call. So we use some sort of set generate debug information, and after that it should actually inform parent class of that configuration container that we have changed that value. And after that we could actually split it so that we will have a field. I have added here underlined prefix, so we create like generate debug information, and we create two accessor function for getting or setting that field value basically. So one of them is actually obtaining that field value, and the second one is setting that one. So after that it's set, so we should have here some function call to parent that indicate that we have changed that value. One of approaches which we could use is actually we use this new C++ extension, so declare a specification property, and it can actually use get or put to call functions. So whenever we assign in generate debug information, this is actually a C++ property, it will actually result in a function call to set generate debug information. And whenever we are getting that value, so it will actually result in get generate debug information function call. I'm not sure how portable this declare specification is, but what I have checked through, it should be supported at least by CLang compiler. So like we saw, we have already written about 11 lines of code, and this is only for one property, and it still does not support parent notification or runtime reflection. So that's why this 11 lines of code could actually be wrapped up behind one define. So as a result, we can get actually this property defined behind reflectable macro, and that will basically create all necessary stuff for us. Then we need to notify the parent class about our property changes, and in order to do that one, we could actually create some base class, call it reflect class, which shall provide on after set property function call, which is virtual function which can be overridden by the developer itself. That function would have default implementation, and that default implementation would be simply collect all necessary information about those property changes and inform parent about that property change. So if we have multiple one class inside another class, so by using one function call we can have multiple return back until we reach the parent class, so topmost class. We can also create additional template class, so reflect class T, which would actually provide a bit more information about the class itself. So it requires the class type name basically, but this reflect class T would actually will be derived from reflect class, and basically will have all the same base function which reflect class has. Let's now take the original code and place it on the left side, and let's create table where we could identify what will change from one step to another. Basically, originally we had enumeration type, and the property name was called like generic debug information, so it's directly taken from here. And if we go to class which is owning that enumeration, its property will be called like debugging, and it will have some class underneath which is derived from the reflect class. And in similar manner we will have also parent class where the property name will be named as linker, and it will be also derived from reflect class. So basically from this table you can see that all complex data types will be derived from the reflect class. Based on previous table, we can create this kind of one step for reflect path walkthrough, and we will have their type information, property name, and the instance itself. So one thing to note that this is already as a base type, so reflect class pointer, which can be actually casted to this pointer of original class. And basically we keep it as a base class, so reflect class pointer, but if we want to restore this pointer as a void pointer, we can use this kind of reflect get instance function call. We are walking across multiple classes and across different class types, and basically each step we take in that one will be recorded as its own step in this vector. Originally we had function call like this, and it would actually trigger this function call, and we basically record the value provided in that function call, and after that we need to provide that information about updated value to the parent. And basically it could be done so that we create instance of reflect path, provide their type, property name, and also the pointer itself, and then we call on after set property, which will continue further to parent class. In reflect class we have additional information about its parent class, and if it's topmost class instance, then that will be set to null, and so basically it does not have any parent. And then we have default implementation for on after set property, which is virtual function and can be overridden by developer. And its default implementation is basically pushing some additional information about the patch, so basically type, property name, and instance pointer, and after that it is calling parents implementation on after set property. And finally the function call sequence actually reaches topmost class with its own implementation on after set property, and that one could perform some additional updating XML nodes or any kind of serialization which it needs basically. And as a base we use the path information which was basically provided in that vector steps. Let's try to set breakpoint in this function call, and let's see what will actually happen. So after reaching that breakpoint, I will go into VC configuration, and there we have function on after set property and set the breakpoint here, and we'll run it again just to check what is happening here. Let's now try to track down what is happening here in the code. So we had here some assignment happening, which actually results in set generate debug information function call. That function call is not so visible because it's collapsed behind defines, so it's not so trivial to debug that function. But that one in a turn is calling on after set property, which results in function call in reflect class. And actual class instance is linker debugging conf, and since we are running here in reflect class, so this is actually a reflect class pointer. And if we now go in the next call sequence, we will see that there is linker conf pointer, which is again reflect class base pointer. And at the end we will end up in topmost function call. So this is actually overrided virtual function call, so it resides in VC configuration, and as a topmost function call it can actually generate any kind of XML data which it needs based on the information provided by path. And path basically records the type information where we walk through, property names, and the instance pointers. So basically path has all the information needed to create any kind of complex XML structure. After creating such child parent class hierarchy, um, we could say that child classes normally does not have any functionality on their own, so they are just acting like containers. So they provide C++ reflection information to parent class, and all magic is actually happening inside parent class. Here is one example of such child class container. So it's basically one class which is derived from reflect class, so it's basically reflectable, and additionally we list here all necessary properties which we want to use. But this class does not have any serialization on its own. Serialization is something that is happening on parent class level. One question which you can ask is, what about portability? So we could actually change the development environment, switch Visual Studio, or use different compiler. And in Windows currently it's possible to develop, for example, Android project, and they are using C-Lang compiler, for example, and they have completely different project configuration pages. And typically, from my perspective, API and classes can be designed rich, that is supporting multiple platform and multiple UIs, and basically it's matter of what kind of path information we will use. So depending on IDE or compiler, we can have different path, but it can be still centralized in one place. This C++ reflection library was designed for project generation tool, and main target is to make C++ scriptable and debuggable. And basically, if you are interested, feel free to contact me, and basically I'm searching for people who would like to help either with scriptability or portability to different operating system or IDEs. I will attach all GitHub links and the link to this PowerPoint presentation slides in video information below. Thank you for watching.